Okay. So that was all about blocking, and now we will talk about deadlock.
So one question.
Huh?
So what do you find in $V lock?
$lock. Okay. So let us talk about $lock. In $lock.
So there is a DB underscore lock view.
DB underscore lock view is not there, no. I think DB underscore blocked underscore sessions. These are the views which are created by some of the scripts in RDBMS admin directory. They are not there by default in most of the cases.
I will find that there is some view like.
There are DBA blockers. Those are the views. I don't think there is a DBA lock view. I think. No. Yeah, DB underscore lock. No, I don't think so. This is $lock. This is the view. $lock is the view which will show you all the locks that are currently acquired by currently running existing transactions on all the objects. So let us say there are 5 transactions that are going on. So in $, transaction there will be 5 rows. $, transaction there would be 5 rows, and one transaction may have acquired 10 different locks. Why? Because it has deleted one row from here, maybe other row from somewhere else, other row from somewhere else. So you will see for one transaction maybe 20 lines in $lock. And from that $lock you can find out which object has been locked. All those things by joining this and this can be found out. These joins are a little bit complicated. So that's why Oracle has created certain scripts inside their RDBMS admin that I will give those. So you run those scripts, it will create certain views, and those views will actually show you the transactions. It will not just show you transactions, it will join these 3 important tables. $, session. In $, session you're going to find out the user information. It will join it to the $, transaction. Here it is going to give you the transaction information, and transaction is going to lock you is going to show you what locks are acquired by that transaction, and then this will be joined with DB underscore objects. Okay, DB underscore objects is going to give you a list of all the objects. So which user through which transaction has locked which object. So this kind of a join is there in those views, and that will show you what kind of locks are there. And what is the best way to release all the locks? Commit the transaction. So commit the transaction is the best way. It will gracefully release all the locks. But as in the example that I was giving you, that if the user has gone home and then he has locked his session, he has locked his terminal, so nobody can go and commit his transaction, so you have to kill his transaction. The moment you fire that alter system kill command, which we have seen earlier, alter system kill command, SID and serial number, then at that time what happens? Then a PMON process is notified. PMON process is notified saying that we would like to kill this session. PMON process then identifies what transactions are going on for this session for that user, and then what are the locks that this guy has acquired. So PMON is gonna do 2 things. PMON, number 1, it is gonna roll back. So obviously PMON is going to use undo to roll back all the things that this guy has done. When the session is killed, so if the session has deleted 10 rows and I'm going to kill the session, what happens to those 10 rows? Those should come back, because the user has not done a commit, and so we're going to assume that the user would like to bring it back. So we're going to bring those rows back, because we are committing we are killing the transaction. We are not committing, we are killing the transaction. And B is release all locks. This is done by PMON when we type the command alter system kill. So that is the job of PMON. That is why PMON process is there.
We can, if we want to check the session which is got blocked, we can check it into
$, session.
No, in one log file also. It's adt.pack.log.
ADT
files.
ADT files. Something new. I would like to see.
They're in Oracle Home.
ADT.
Yeah.
Okay,
Work
okay.
directory. It's in work directory.
Okay.
If you type cd $work and you can find ADT files, adt.pack files.
Okay. We'll show it to me. We'll see that. But based on my information, it is $lock is where you will find out the locks.
Also we kill the blocking sessions and we check whether it is whether the queue it's working fine or not. We check into the ADT files.
Is it some of the scripts that you guys have created earlier?
Yeah, right. To kill the session, we create a script.
So it must be created by some of the DBAs at your location. So
By us only.
so those are the scripts that are specific to your shop. They
It's a common file where all the log and all the packets get stored in the with a warning session with the error sessions.
okay. We will see that. We'll see it then. So what was I saying? PMON is the process which will do all this stuff. So since we are talking about PMON, I will divert a little bit from this topic, and I will also mention what are the other things that PMON does. We have seen this on the listener side. Dynamic registration is done by PMON, so that is a different discussion. But another thing that I would say, that let us say this is a SQL Plus session that I have on the client side. Client gets connected to the server. Client first gets connected, connects to the listener. Listener is going to tell the client, please do not connect to me, please connect to the dedicated server process. So client then connects to the dedicated server process and so on. And suddenly, let us say in a situation that the electricity from the client side goes off. That means client suddenly dies off. The client was in the middle of a transaction. The client had just executed a command to delete 100 rows. What happens to those rows now? So PMON is intermittently doing a check of the connectivity to all the clients. PMON will identify that this client has been lost and the dedicated server process is still running. At that time, PMON will do what is called as a cleanup activity, which means the same thing. It will roll back the transaction of this SQL Plus session and it will release all the logs. So that is done automatically by PMON. So PMON has the cleanup activity, whether it happens through the alter system kill command, or whether the client dies off, or the listener kind of registration that we had seen earlier, that is also done by PMON, process monitoring. So that was a little bit of a different discussion there. That is the activity of PMON. So now,
What's this?
process monitor, PMON, yeah, process monitor. Now about the deadlock. What is the difference between a lock and a deadlock?
Some time. Deadlock is after.
Deadlock is like forever.
Yeah.
Deadlock is, I think you are correct. I mean, deadlock is kind of forever, and therefore in earlier versions of Oracle, deadlock was a bad thing because Oracle could not identify the deadlock. One guy is blocking another, this guy is blocking this, and we'll see what a deadlock is. And therefore, identifying deadlocks and killing the session was a job of a DB at that time. This time in Oracle's newer versions, we don't have to do it. We just have to kind of make sure that we understand what deadlock is, and we have to monitor whether deadlocks are happening too frequently in our system or not. That is the only job that DB has. So let us first understand what deadlock business is. Okay, so I believe I have a I think I will use that example, which is easier for me to go through. Or I could have used it here also. So this is user A and this is user B. The user A is now, okay, I think I should have used the same example here. Maybe 101, 102, 103 and 104. And these are the employee IDs, and these are, let us say, the salaries. 1000 is the salary, 2000 is the salary, 3000 and 4000. So these are the salaries of that employee table. So user 1 comes in and he updates the salary of this guy. Using the update statement, he updates the salary of this guy and he changes it to 3000. Okay, the moment he updates the salary to this guy, this row is now locked. So this row is a locked row by this user. The other guy comes in now, he is updating the salary of, or not a salary, he is updating maybe some other column, maybe the address. So this is the address or city. So he puts the city as Pune. So this row is now locked by this guy. So there is a lock over here by this guy, there is a lock over here by that guy. Now this guy comes in. So this guy comes in now, and he is going to now execute a update of a salary. He wants to update this salary. So he wants to update this salary to 4,000, but what is going to happen? He will not be able to update that because there is a lock by another user. So he will wait indefinitely. He will wait indefinitely, and then what? This is fine. Up till now it is just this session is blocking this session. So what is happening here is blocking now, not deadlock yet. But now this guy comes in and he wants to now update this to Bombay. So now this guy wants to acquire a lock on this, but this is acquired by this guy. So what is going to happen? Whatever I require is locked by this, and whatever you require is locked by me. So I'm not going to give you what you need, and you're not going to give me what I need. And therefore it's a deadlock situation. Then nobody can go further. Nobody can go further. And this kind of a situation, again, what will happen? Nobody can go further. But Oracle has now written algorithms so that this situation, which is a deadlock situation, can be identified automatically and it can be resolved. How can it be resolved? By basically killing one guy. Okay, getting rid of one guy, and Oracle will, will get rid of this guy. So he will actually, this guy will get what is called as Aura 660, I believe. Yeah, no, Aura 60. Aura 60 is a deadlock detected, and that error is going to get rid of this guy's transaction. This guy will go ahead further, and then little later on, once he commits, this guy can come back and continue. Whenever deadlock happens, there is a error message written in the alert log file. So you need to kind of identify those deadlock errors over there, and those things will continue. So deadlocks, not a good thing from the programming point of view. One user has to kind of back off, and Oracle will do that for them, and things will continue. So in earlier days, whichever was the problem, that whenever deadlock happens, nobody could go further. Here at least one guy can go further, the other guy has to back out, and Oracle is going to do that automatically. So that is what a deadlock is. So deadlocks are detected automatically. That is there. And now what I want to actually discuss is the locking in little more detail. Like what kind of locks are acquired when we do the basic DML statement. There are quite a few locks. I want to go over the basic important locks. So insert. When we do an insert here, what happens actually? So there is a, obviously we are inserting a row, so there is an row level exclusive lock. So for that row, the row is exclusively locked by that session. Row is exclusively locked, and because the row is locked exclusively, nobody else can do anything with that row. So that is the row level exclusive lock. But also there is one more lock that is acquired. Table level lock is also acquired. A table level shared lock. A table level shared lock is acquired. Which means what? Okay, I may not be able to do anything with that table, but I am also working with, let me repeat that. I'm doing something with that row, so nobody should mess around with that row. But I am also working on that table, obviously, and therefore nobody should mess around with that table also. That means altering the table. Okay, even though altering a table will not modify any data, but altering should not happen, and that's why the row level lock is also required. So this is what happens when we do an insert. So what will this allow us to do? Other people will be able to do any a DML operations on any other rows except that row. Select statements will not show this row. So this is this, and then table will not be able to drop, will not be able to be dropped. Update, same thing, row level exclusive. And table level shared, and delete also. Row level exclusive and table level shared. All those insert, update, deletes will actually make sure that you have a row level as well as a table level lock. Now all these things are happening automatically, and that's why we say these locks are implicit lock. Implicit lock means we don't have to execute any commands to acquire a lock. All those things are happening automatically. The locks will be released when we commit or rollback. So these are the main things that you need to understand: insert, update, delete, row level exclusive and table level shared. And what is the purpose of a table level shared? That no other guy is going to do any kind of modification to the table, dropping of the table also for that matter. Okay, will not happen during that time.
So what difference is exclusive and shared?
Shared means you can do any other things on that object. Now table level, people can do any other DML, any other operation on that table. But for that row, nobody can do anything. Nobody can do anything. Now, for example, even select, is there any lock acquired during select? The answer is actually yes, there is a lock acquired during the select also. And what kind of lock? It's a shared level lock, which means I'm doing something with this thing. You guys can also do it, but don't do something crazy to drop that table or something like that. So, why dropping table is crazy thing? Because and that's why dropping a table requires an exclusive lock at the table level. Exclusive lock at the table level. If I want to drop a table, nobody should be doing anything on that table. Nobody should be doing anything on that table. So those are now DDL locks. So these are DML locks. Insert, update, deletes are DML locks. So DML locks has those kind of things. Now DDL locks, so create, drop, alter, all those are now DDL locks. Create, drop or alter. These are the DDL commands. Now when these commands are fired, automatically an exclusive lock is acquired on the object which is there in this create or drop or alter command. Exclusive lock at the object level, not at we are not talking about data now, we are talking about the object. So at the table level, the table is exclusively locked. Okay, let us say I want to alter a table. If the alter takes 3 milliseconds, I want to change the data type of something. For those 3 milliseconds, the table is locked exclusively, and this type of locking is the DDL kind of lock. And what happens because of this DDL lock? It will prevent other users from using any DML statements or the select statements. DML or select statement will not be able to execute until that alter table happens. So each lock has a certain effect. Each lock has an effect. So exclusive lock at the table level, that is what is happening here. Now I will give you another example here, since we are not PLSQL guys. Creating an index. Okay, I am creating an index. Index is based on a table. So while the index creation is happening, let us say index creation is happening for 5 seconds. During that 5-second period, obviously, I will have an exclusive lock on my index itself. But at the same time, I will have a shared lock on the table on which the index is getting created. And during that 5-second period, nobody should be able to drop that table. So now the shared, this is exclusive shared. What is a shared DDL lock? So we are talking about DDL locks. Exclusive DDL lock is actually on the table itself. I am altering the table, then the table should not be, nobody should be able to do any DML or select statement. Now the shared DDL lock. Shared DDL lock is, I am creating something which is dependent on something else. And the dependent object is going to be locked in a shared mode so that nobody else should be able to do anything else, which is detrimental to my action. My action is to create an index, so I'm gonna lock the table in a shared mode. Another example is this thing. I'm creating a stored procedure, which is a PLSQL program. Inside my PLSQL program, I have to while I'm doing a compilation of the PLSQL program, I have to lock the table from which I'm selecting. in the compilation of the PLSQL. So during the time of the compilation of the PLSQL program, which may take 2 seconds, during that 2-second period, nobody should be able to do an alteration or dropping of the table which is referenced in my PLSQL program. So these are some small things. I mean, we don't need to, kind of do anything. We just need to understand that these could be problems. Deadlock could be a problem, locking could be a problem, and this understanding will give us a better, troubleshooting skills if we know these things. So there are quite a few other types of locks, but I would say in DDL, exclusive and shared, and you need to understand what they do. And in also DML, we have exclusive at the row level and shared at the table level. That is a DML lock. So these are the locks that we have, and the data dictionary views that I have mentioned is $lock, $transaction, DB_objects, and $session. Those are the views that usually you would find out. And I think killing the session, we have seen that. Okay, so I think this is all I wanted to discuss about locking also. One small thing that I would mention now is about latches, locks and latches. Don't want to go into too much of detail, but here latches and locks, basically both of them are some kind of locks. What is the purpose of a lock? The purpose of a lock is that if I am doing something with certain object, you should not come and mess around with that object until I am done. So I am going to lock that object, whether it's a row or a table or whatever it is, and then you come and you do whatever you want, and you wait in the queue. Okay, because I am working on this thing, you come and wait in the queue. Once I am done, I am going to release the lock. Now you come in. If third person wants to do something, he comes in a queue. So all the locking happens with the queuing mechanism. And then one person is waiting for other person is waiting for third one, and all that stuff. So that is what the queuing mechanism is. And this is all for rows and tables and all that stuff. Similarly, when we talk about the SGA, what is in the SGA? The buffer cache. The memory areas are there, buffer cache, library cache, and that is a shared memory. Okay, we may have seen that SGA is the shared memory, which means what? Which means multiple processes are manipulating the information in this. And this part of the SGA, that part of the SGA, that part of the SGA, all that stuff, those are now being manipulated by the DBW or LGW or PMON, dedicated server process, all that stuff. So managing this area of the memory will require also certain kind of locking mechanism, because one user process is reading from that, other user process is writing, all that mess up could get created. So the locking mechanism for the SGA components is provided by what is called as latches. And they are very quick. They are just kind of 1 and zeros and ones, on and off kind of a thing. That means this is acquired lock, and everything is in an exclusive mode here. That there is a lock on this memory area by a certain process, or there is no lock. So it is either on and off, either exclusive or no lock. So latches are always in an exclusive mode, always. Locks can be in shared and exclusive mode. So that is one difference there. Always exclusive, and this can be exclusive or shared. This is for objects and rows and everything. This is for the memory area. And you must have heard about semaphores. Semaphore is a mechanism to do or help locking inside the memory area. So when you set up semaphore during the kernel, the Oracle installation there, then those are for locking the memory areas. That is what latches are for. So we can go into much more detail here. There is no another thing difference that I would say here. There is a waiting. Yeah, there is always a queue here. One person waits after another person. There is no queuing. No queuing. No queue. That means if I want a resource and it is locked by somebody else, I will not queue up and wait for that. I will go and do my job, and I will, after certain time, I will come back and see if the resource is free or not. So there is no queuing. In the meantime, if some other guy comes in and he takes it, okay, my bad luck. So there is another process comes in and he takes the latches, he takes up the latch, then I'm too slow. So no queuing over here, and there is a lot of queuing over here. So there are multiple differences, but final thing that we need to remember is that this is for providing the read consistency or basically consistent view of the data, whether it's the actual data or the shared memory areas. This is usually heavily used, semaphores are heavily used in shared memory management. There are two processes going after the same shared memory. That's why we need semaphores.
So what semaphore actually do?
Semaphore is a flag. In a layman's term, it's a flag. It's a it is turned either on and off, which is going to tell you whether a specific memory area has been locked by somebody else. Somebody else means some other process or not. That is what a semaphore is. That is the operating system terminology. Latches is the Oracle terminology. So latches are implemented using semaphores. Latches are implemented using the semaphore method. Yeah, technology. Anything else on the locks and undo? Now, okay, so one last now discussion or one question for all of us. User A and user B. Two different users. User A and user B. Okay, this user now there is a table here in the middle. This user says insert into table T1 values 10 and let us say A. 10 and A. So 10 and A goes in here. Okay, at this time this user comes in and he says select star from A, select star from T1. What will he see? Nothing, because this guy has not yet committed. So this guy has not yet committed, so he sees 0 rows. Now this guy comes in and he says delete from T2. So T2 is another table, and there are currently 2 rows there, or 3 rows there, 11, 12 and 13 P, Q, R. So these are the rows in T2. This is the T2 table. Delete from T2. This guy comes in and he says select count star from T2. What will he see? 3, because this guy has not yet committed. Now third thing is this guy says alter table T3 and add, and it's going to add a column. Let us say column is name and varchar, something like this. So he's adding a column. The name of the column is name to table T3. So this is table T3 and the column will be added there. Okay, so all these are different operations, one on T1, another on T2, third on T3. Now after this happens, this guy is again adding insert into T1, again insert into T1, and now the another row comes in there with this thing. All this stuff is going on. My question now at this last moment, when he has done an insert into T1, how many rows or what will this guy see if he selects from this table?
1 row.
0 rows.
In
T1.
what?
In T1, see, so this is the first statement, second statement, third statement and the fourth statement that this guy has executed so far. My question is, after executing the fourth statement, what will be the count for this guy in T1?
1 row. Because alter is there.
1 row or 0 rows? We're saying, you are saying 0.
1.
0.
1.
1. Okay, so we have only, anybody says 2? Because he has inserted 2 rows. 0. So let us discuss what is happening here. This guy is doing an insert. The correct answer is 1. The correct answer is 1. So let us see how it works. Insert into T1 values. So one row is inserted here, but not yet committed. So this guy still says 0. Then he comes in and he deletes from T2, but still he has not done a commit. So this guy will also see 3 rows from here. No commit has happened so far. The transaction has started at this point. Okay, transaction is happening. It is going on. This transaction has locked 1 row. Sorry, this insert has locked 1 row. This delete has locked 3 rows. All that locking is also happening. Undo is getting created, but transaction is still not finished. Alter table T3, some other table, and then add column something. Now what has happened here? The table T3 has been altered, and then what?
Auto commit is happening.
Auto commit. It means the commit command has been executed immediately after the third statement. Auto commit means after the command, the commit is going to be executed, and therefore whatever has happened so far from this point and this point is committed. So therefore this guy is gonna now suddenly start showing that 1 row is committed, these 3 rows are gone now, and table has also been altered, and the commit command has been executed. Because of that commit, everything has been made permanent. And then finally this guy says insert into T1. He inserts 1 more row, but now this second row has not been committed yet. So now this guy comes in, he says select count star from T1. He will say this row which is committed. He will not see the second row, it is not yet committed. So select count star from T1 will show him 1 row, and if he wants to do the select count star from T2, he will see he will see 0 rows. Yes, because those have also been committed. 0 rows, that is correct. So that is what an auto commit means. Auto commit means not just you delete your own, you commit your own command, you commit everything that has happened till that time. That is what an auto commit is. So a very small point but a very important point here. ठीक है, we'll